The Compton Effect. After the X-ray photon being emitted from the X-ray tube reaches the patient, the X-ray photon passes through the patient's body and interacts with the patient's atoms. At this point, several interactions occur. One of those interactions is the Compton effect, also known as modified scattering, incoherent scattering, or Compton scattering. Compton scattering is responsible for 99% of the fog in the image. This is very destructive to the image and it must be controlled. But first, let us explain how this interaction occurs. Compton scattering occurs when the energy of an incoming X-ray photon is much greater than the atom's binding energy. This effect occurs in the outer shells of the atom where the atomic draw or pull is the weakest.
It's such a good vibration. It's such a sweet sensation.
When an incoming photon interacts with an atom's orbital electron, it partially absorbs the energy of that photon and causes the electron to be ejected from the atom as a recoil electron. Since there is still energy left over from the incoming photon, this energy is then re-emitted as a secondary Compton photon, also known as a Compton scatter photon. The Compton photon does not travel in the same direction as the original beam emitted from the X-ray, and it may be scattered in any direction. Scatter radiation from Compton scattering may reach the film, exposing it and creating a blanket of gray density over the entire image known as fog.